All right, now we're going to do some examples of graphing from slope intercept form. So here we have 4 different equations. In each case, it's in slope intercept form, meaning we can read the slope and the y-intercept directly out of the equation. We'll color code these so they're all going on the same graph, but they'll be matching colors to the equations. The one thing I want you to know is that we'll also ask you the reverse. We'll give you a graph and we'll ask you for the equation. Realize it works the opposite. So that's part of your learning, is to figure out how that part works. So here in this equation, we have a y-intercept of -1. That means we cross the y-axis at -1 right here. And we have a slope of -3. So from this -1 point, we're going to go down 3 and over 1. We're going to go down 3 and over 1. We can also go back 1 and up 3. And we should draw a line with a ruler. And here is that equation. So there's the first one done. Slope of -3. It's a fairly steep up and down, going down line that goes through -1 on the y-axis. So this is -1, this is -2, this is -3, this is -4, etc. It's -5. Okay, so we'll mark that y-axis a little bit. Y, X. You put arrows on it if you want. As I said, I don't really care that much about arrows. All right, next line. Next line looks like we have a slope of 1/2 and a y-intercept of -5. So here's our -5. Our 1/2, we're going to go up 1 and over 2, up 1 and over 2, up 1 and over 2, or back 2 and down 1, back 2 and down 1. This has a positive slope in general, right? Our slope is a positive number, so it's going up as it goes towards the right. It's going in the direction that we read in. And we can draw a line through those points like that. The next one doesn't have a y-intercept. It's not shown there. When something doesn't have a y-intercept, we assume that it is +0, right? So it has a y-intercept of 0, so it goes through the origin. And it has a slope of -1/3. That means it goes down 1 and over 3. That's not the same as 3. 3 was down 3 and over 1. But this is down 1 and over 3. So down 1 and over 3, and down 1 and over 3, or back 3 and up 1, back 3 and up 1. And again, we can take our ruler out and draw a nice line through the origin, right? It's not going to show that y-intercept. Now here's a tricky one. This is in slope intercept form, just is missing everything. There's no slope shown. There's no slope shown, and there's no y-intercept shown. So when no y-intercept is shown, again, we are assuming it's +0. When no slope is shown, well, we do have an x here. That doesn't mean, that means we don't have 0x. We have 1x. So the number that's shown here, that isn't shown here, is that m equals 1. So we start at the origin, and we go up 1 and over 1. That means, m equals 1 means the rise and run are both 1. So we go up 1 and over 1, up 1 and over 1, up 1 and over 1, up 1 and over 1. Or we go down 1 and to the left 1, down 1 and to the left 1, down 1 and to the left 1. And we wind up with it's called a perfect diagonal, or at least that's what I call it, through the origin. It's like a 45-degree angle. It has a slope that goes through every integer point there. And there's the orange line. All right, so there's 4 quick examples of slope intercept. Now, if we were to give you a line, you should also be able to determine the equation from the line.